So hi everybody. Thanks a lot for joining on to the OLake's monthly sessions. And this time we have been joined by Alex. And we at OLake have been working on diving into the Apache Iceberg ecosystem and also making the people aware in our community how this ecosystem is evolving. One of the very integral things that we revolve around is building the world's fastest data replication tool. So if you are a person who is looking around to build around Apache Iceberg, or if you're someone who is looking forward just to get around data replication, OLake might be a tool you might be looking forward to. So once we go ahead and wait for the other people to join in, we are just looking forward for have a good fruitful discussions. Our questions tab you might be seeing over here. Just drop in whatever questions you have at the particular point of time. Feel free to do that, and also drop into a chat, tell whatever questions you have, or also wherever you are joining from. So like I'm from joining from Bangalore. Alex, where are you joining from?
Oh, I'm joining from Orlando, Florida. So in a few weeks I get to be home.
That's cool. That's cool. Yeah. So, guys, we're going to be starting in around a minute or so, the complete introduction and everything. So, if you want, by then you can use our chat. So yeah, let's jump on to the formal introduction side of things, shall we? So OLake is the data replication tool which provides you the capability of syncing your data from your databases, the one you name like Oracle, MongoDB, SQL, anything around that, or Kafka, all the way to Apache Iceberg, like the one of the table format that is being rapidly being adopted. And that also brings us to this session. Not only that, we have been joined by Alex Merced. He's a renowned voice across LinkedIn, blogs. Personally, I've been following him. All the people in my team have been following him. We, like a lot of my people and the friends, go ahead and look out him at various meetups. So that's been a very, very interesting side of him. And I guess a very go-to book for every other data engineer out there, the Apache Iceberg Definitive Guide. I guess everyone would have read it. So he's one of the person who have authored it. So like that's a very very great thing. So we have invited him, and it's a great pleasure for us to have him on this particular session. So yeah, Alex, could you go ahead and say like a quick hello, like what are you building over there at Dremio, and like tell folks whatever you're going to be covering into the session before we dive in completely.
Hey, everybody. Again, my name is Alex Merced. I'm the head of dev role here at Dremio. Now, Dremio is we like to refer ourselves as the intelligent data lakehouse platform. So if you're someone who is executing an Apache Iceberg lakehouse in particular, you're going to generally run into sort of like three problems that we provide fun solutions for. So one is one, having to stand up a catalog. So we do have a built-in Dremio catalog that's built based on Polaris. So just by having the Dremio platform, you already have your Iceberg catalog. Now, for the tables that are in that catalog, we will automatically optimize them for you, so that way you don't have to worry about optimizing those tables. And we have a query engine that can federate queries from Iceberg with other sources like SQLs, really databases, NoSQL databases, data warehouses, data lakes. So that way you can kind of work with all your data in one place. So we just kind of provide you that one sort of pane or window pane into all your data into your lakehouse.
Yeah. Yeah, so like that's pretty cool, guys. So like if you anyone out there, just go ahead and search anything around data engineering. Like one of the few articles that pop up of Dremio, like he is one of the mastermind that is going around and developing them. So like that's one of the good things. So like I have a brief question on that. So like you are a huge community guy, right? So like you have been building, you have been telling the people around it. So like I'm also been one. So like if you will just go ahead and tell the people of how like if a person wants to go ahead and engage in the Apache Iceberg community, or like contribute via blog post, like what his go-to should be.
Oh, okay. So basically, bottom line, if you want to participate in the Iceberg community, there's sort of a couple different ways to do it. Of course, if you're a software developer, we can always use more people committing code to the actual Apache Iceberg project. But there's always things that an open source project needs. It needs a community and documentation. So also, go if you've been hands-on with Iceberg and you see like, hey, there could be some more detail in the documentation, going in there making commits to the Apache Iceberg documentation, or two. And then there's the community piece, which comes in two flavors: events and blogs, or written content. So basically, if you have blogs that you've written about Apache Iceberg, or you've done a podcast about Apache Iceberg, I do actually run a website, lakehouseblogs.com, where you can commit your listing of your blogs. Used to be hosted over there as part of the Iceberg website, but they've recently decided to stop hosting the blog list. So then I created lakehouseblogs.com to be the new home for the list of blogs in the open source data space. And then also events. Okay, and basically right now on the Apache Iceberg Slack group, which you should definitely join the Slack group if you're not part of the Iceberg Slack. It's not only just become a talk for development, it's just become a place where the community really just kind of uses the kind of touch base with each other, and we all message each other and whatnot. So it's like I probably use the Iceberg Slack just as much as I use my work Slack. But there's channels that like are prefix meetup, so like Meetup Bay Area, Meetup New York. And if you join those channels, you can get involved in either organizing events or discovering upcoming Iceberg events, and just be part of the community. So those are all great ways to just kind of be involved in the Iceberg fabric.
That's cool. That's nice. So, guys, if you want to go ahead and get in touch with the Apache Iceberg, like one of the fastest ecosystem that is growing around in data engineering, you should definitely give it a good outlook. So, yeah, like without further ado, guys, like hi, I'm Akshay. I'm gonna be a host for the today's session, and I'm gonna be taking all of your questions in the questions tab, attending all of your talks inside the chat, and also taking care of whatever conversations you want to have with Alex. So I'm gonna be a go-to person. I work as a DevRel here. I manage everything around documentation, blogs over there at OLake. A lot of my intelligence also comes from the Alex side as well. I've learned a lot from him. So I hope you guys also will go ahead and look out most from this particular session. So let's dive into the agenda. So like this session gonna be diving more into the side of the catalogs and why traditional or even the closed catalogs go ahead and often slow the teams down, and why we are going ahead and exploring Apache Polaris, the open source catalog. Uh, Here, Alex will go ahead and dive deep into it, why the need of open source catalog is, and why we have other solutions. For example, you might have heard about AWS Glue as well, right? Or you might have heard about Unity. Why the need of such catalogs are emerging. So I don't need to give much introduction, but on the Alex side, but yeah, like he has over 10 years of experience, so like that's a very very big number. He has been a part of very much talks and podcasts, and the recording of this particular session and everything, the slides will be shared with you guys over the mail, so feel free to check them out. So yeah, Alex, now the stage is yours. You can go ahead and start off.
Sounds good. Let me share my screen. Let's get this
Yeah,
going.
let me. Yeah.
Cool. Okay. And there we go. Hey, everybody. Again, my name is Alex Merced, head of DevRel here at Dremio, and welcome to this presentation. We'll be talking about Lakehouse catalogs. A little bit about me. Again, I'm the head of DevRel. I've basically been with Dremio for just about 4 years now, where I've gotten to spend the last several years talking about the data lakehouse, Apache Iceberg, Apache Polaris, Nessie, Apache Arrow, just talk about open source data in a big way. And part of that journey, I've gotten to write a few books. So here are some of the things I've gotten to contribute to. And you can, all of these ones that you see on the screen now, you can download for free. So if you scan this QR code that you see on the screen, you can download all 3 of these books for free. There's links there. Also, you'll find on the page that this QR code will take you to is you'll find links to sort of demos, tutorials, hands-on tutorials, so you can get hands-on with some of the stuff that I've talked about today, and a lot of other really good resources. So do scan that QR code. Do download these books for free. I do have a 4th book that I'm working on that is not free, but that you'll also find a link for that there as well. But this will give you plenty of iceberg reading in the short run. Okay, and on a lot of good topics. So this is like the 4th book. I do raffle this book off everywhere I do a talk. So if you want to participate in the raffle for a free copy of this book, do scan this QR code, and I'll do the drawing and email the winner in a few days. Okay, so again, this is to win my latest work, which is architecting an Apache Iceberg Lakehouse with Manning. Okay, that one's been, that's the first one I've done completely solo. It's definitely been a lot of work, but it's gonna be cool. It's less what is Iceberg, more about like choosing a catalog, choosing a storage layer, choosing your ingestion tools and your query engine. It's about the actual architecting of the components of the lakehouse. And one other announcement is that we at Dremio will be holding our conference, Subsurface, over the next, basically starts like this week and over the next month in different locations: Paris, London, Nuremberg, San Jose, NYC. So if you're in any of those markets and want to register, head over to dremio.com/subsurface. And now let's begin with our featured presentation. Dun-dun-dun. Okay, make it feel like a movie. Okay, but let's level set. Okay, I always like to level set. So what I'm going to do is I'm going to talk about what is a catalog. But to understand what is a catalog, we need to understand what the catalog, like data systems in general. So let's talk about traditional data systems. And we have traditional data systems in the forms of databases and data warehouses. And we love databases and data warehouses because they do lots of things for us. They abstract away things like storage. How is the data stored? They abstract away the table format. Like how do we know that this data belongs to this table and this data belongs to this table? Somehow the database and data warehouse understands this under the hood. It's already figured that out. Separately, how do we know what different tables are available in this particular system? That's the catalog piece. So again, a catalog, I just think of it like a phone book. Okay, so it's like a listing of things that are there. So, while I can go into a phone book and find out who's in my local area and what their phone numbers are, in a data warehouse or database, I can find the catalog, which would then help me discover the tables that are there and where they're stored. And then there's the processing piece of a database or data warehouse that allows me to write a SQL query, parse that SQL query, turn it into an execution plan, and then actually execute that query. Now, this allows me to work with my data, whether we're talking about transactional data stored in rows or analytical data stored in columns, okay? But there is sort of a catch, okay, which we'll come back to. But the bottom line is that each system does it differently. So the problem is that these systems can't talk to each other. So when you start getting to larger companies that have interdepartmental warehouses, if the sales department wants to share data with the finance department, they oftentimes are doing ETL between their different data warehouses because they might be using different tools, okay, which causes, cost, friction, loss of time, things like that. But in these systems, again, but inside database and data warehouses, there is a catalog. Okay, and again, the catalog is like the listing of tables. But the problem is like the word catalog in data is a little bit overloaded because there's other things we call catalog too. Okay, such as like enterprise data catalogs. These are like your Elations, your Colibras, your Atlans. Okay, these are different. What they do is they build like a data marketplace. Okay, where you can organize a listing of all your data, not for your system to understand. So again, the catalog in your database or data warehouse was for the system to know what tables exist. A enterprise data catalog like Atlan, Calibra, Elation, etc., those are built for humans to understand what data exists. So essentially, I'd be able to go on like some web page and see, okay, hey, we have this sales data that's in Postgres, we have this click stream in Kafka, and I'd be able to like request access to that data set. Okay. So again, when people say data catalog, data catalog, data catalog, you got to be very careful what they're talking about. They're talking about what's oftentimes a data catalog. We're talking about something like this. Again, the Elation, the Atlans, the Colibras, the data hubs that are for a human to discover data and request access to data versus a system. When I talk about like a metadata catalog, like we'll be talking about today, I'm talking about the thing that allows the system, the software, to discover what tables exist and operate on them. So now that we've kind of established that these two different sort of thoughts in the catalog world, then the question is sort of what is a data lakehouse? So we mentioned that we have the problem that with databases and data warehouses that every system stores the data differently, so they can't talk to each other. Okay, they do all of those layers differently. So one approach was to do a data lake. Okay, and with a data lake, what we did is we took storage like an S3 or an ADLS, and we said, how about we just do analytics directly from storage? Okay, we could use a tool like Dremio that can run queries against CSV files, JSON files, Parquet files, XLS files. We could use AWS Athena to run queries against our data lake on these types of files, and that works. You can do some analytics that way. The problem is like it's really hard to do updates. There's potential consistency issues depending on how you organize your data. It quickly turns into what people like to refer to as a data swamp. Okay, so ideally, I notice there's some layers missing. I can remember when we did the database and data warehouse, there was some extra stuff here. What if we put those layers back in? What if I took the storage layer and the execution layer, but then we added a table format so we can actually recognize groups of files as tables? And what if we had a catalog that would track those tables? Okay, then suddenly we have a lot of the features and usability that we had in a data warehouse, but with the flexibility of a data lake, thus the data lake house. Okay, so it's just taking the data lake and making it feel more like a data warehouse. And then you have, but again, part of that is a catalog. So when I think about a lake house catalog, okay, to distinguish it from the catalog that's built into a database or a data warehouse, they do the same thing, but the way the lakehouse catalog works is that it's helping you discover where on your storage your different data lakehouse assets are. So in this case, I might have a sales table, and it's going to say, hey, like the sales table's metadata is located at this S3 location. Oh, I have a products table. Okay, that's located at this Azure location. And then the engine would then access these storage locations to access that metadata and then run the operation on the table. Okay, so that's how that would work. The end result is you end up with a situation like this, where you have your data sources, and now you just ingest your table into your data lakehouse using, whatever, you can use tools like OLake to go then replicate your data from your databases or other tools. But the end result is once you land the data as Iceberg, the tool that writes the data is going to write the Parquet files to your storage. After it's done writing the Parquet files, it's going to then write the metadata that describes the table and then register the table with the catalog. And now what's going to happen is that now all your tools can then talk to that catalog and discover those tables to run analytics, whether it's Dremio, whether it's Snowflake, whether it's Flink, whether it's Spark, whether it's PuppyGraph. They're all going to be able to access your lakehouse. So no longer are you e-tailing data between departments or between different teams to use different tools. Everyone can use the same copy of the data with all their tools. Okay, so that's essentially like the why of the data lakehouse and why the catalog is so important, because that becomes the entry point. Okay, let's talk just again level setting on Apache Iceberg. So again, now that we know what the lakehouse is, again, one of the layers is the Apache Iceberg table format. And the way that works is that once you have your catalog that tracks your tables, an engine like Dremio would go to the catalog and say, hey, I'm looking for a table. And then the catalog would say, hey, that table is located here. So it would point you to the current metadata file. And there's like 3 layers of metadata. So the metadata file is like the top layer that says, okay, hey, this is the table. Here's the partitioning of the table. Here's the schema of the table. Here's the history of the table. And now I would look at the history to find the version of the table that I want to query. Okay, and each version of the table has a manifest list. So manifest list is a listing of all the different groups of files that make up that version of the table. So I would go through each grouping and look at the statistics on that grouping, and I can determine, hey, does this group of files have any data that's relevant to my query? And if not, I can skip it. I can just say, well, I'm not even going to consider that. So I've just eliminated ever having to scan those files. Now, once I've determined which groups of files make sense, are relevant to my query, each group of files belong to a manifest file. And these manifests will actually have the individual listing of each file. Okay. And then I can use the statistics on each individual file to determine should I scan it or not. Now, all these files are written when you write to Iceberg. So in this case, if you're using something like OLake to replicate your data from your source systems, OLake would then be responsible for writing the Parquet files, then writing the manifest that tracks those Parquet files, then writing the manifest list that says, hey, these are the manifests that are part of the snapshot, and then writing the metadata file, and then updating the catalog. Okay. So basically the writer goes through all those steps where, again, writes the data, writes the metadata, updates catalog. That's the write process. While the read process moves the other way around, consults the catalog, discovers the metadata, then accesses the data files. So the way I always kind of think is like writes and reads kind of move in opposite directions as far as like where they go up this tree. Okay. Cool. Okay, I'll come back to that disaster recovery question later on, but that is a very big question. Oh, that's a question about OLake. Okay, I'll let that question be discussed in the chat. Apache Iceberg catalogs. So now that we know what Apache Iceberg is, so we know what a lakehouse is and why we want a lakehouse. We know what Apache Iceberg is and how that works. But we want a catalog to help track our tables. And the catalog is very important because the catalog is the go-between between our storage, which has our data files, and our metadata files, and a go-between between our engines. So when Dremio wants to access an Iceberg table, it needs to go through a catalog. The catalog has to tell it where the metadata is. Okay. Now, the thing is, the catalog needs to tell, hey, Dremio, Spark, whatever, which is the right metadata JSON. The reason being is that every time a Iceberg table is updated, a new metadata.json is created. Okay, so basically there's a new change, new metadata.json. Okay, and the problem is when you have lots of metadata JSONs, because you're doing a lot of transactions, how are you supposed to know which is the right one? That's why the catalog becomes a source of truth. Now, how do you do this? There's a couple of different ways. Originally, there was something called the Hadoop catalog, which is really just the file system catalog. This is generally not recommended for production use cases. It's a good way to like practice with Iceberg and try out Iceberg, but generally not recommended for production. And you'll see why. So the way this works is that we, instead of actually having like a separate system, you have this little file called version hint.txt. And this version hint.txt file has one thing inside of it, the location of the current metadata.json. So then what would happen is that the writer, instead of updating some sort of system via like a REST call, it would just go back and update this file and replace the old, like let's say you used to point to this v2.metadata.json, it would replace the address to this file with the address to this file. Now the problem with that is that then you're subject to the guarantees of the storage system. So certain storage systems have better guarantees when multiple people try to update the same file than another. So that means you can't have potential concurrency issues where multiple writers end up creating not the right updates. Again, not an issue if you have single writer, like only one person's updating the table at a time, but in a multiple writer situation, there are potential issues. So generally this is discouraged for particularly production use cases where you have multiple writers. You wouldn't want to do this. You also don't want to do this because it doesn't really cover access control. As you'll see later on, when you actually have a catalog service running, it can actually handle access control too and track who is trying to access the table and whether they have access to it. So when you use a service catalog, so this is like something like a Polaris, a Hive, Nessie, Dremio catalog, which is powered by Polaris, Snowflake's Open catalog, which is powered by Polaris, or like AWS Glue, what happens is that Dremio would then, or whatever engine would then connect to the catalog, make a request to the catalog, oftentimes via some sort of API call, and then the response would be the location of the metadata. Okay. Whew. Breathe. Sometimes I forget to breathe. Okay. Now, so now we know what the role of the catalog is. Now let me tell you about some of the problems in the early days of catalogs. Now, in the early days of catalogs, everything, like when Iceberg first started, everything was in Java. Okay, so there was only Java. So basically the idea was, okay, hey, you want to create a custom catalog for Iceberg? You can just implement a class in Java and you're good. And as long as your engine has your Java jar with the how to use that catalog in it, then you're good to go. That created a problem because Iceberg expanded. Iceberg also has now a Python API, a Rust API, a Go API. And those languages can't use those Java jars. So in that case, all the logic for each catalog would have to be re-implemented in each language, which isn't ideal. Now, for example, if you're talking about like, let's say it's a hosted service, like let's say like a Dremio or an Upsolver or a Fivetran, you can't drop jars and add additional support for these additional catalogs. Fivetran would have to add support for each individual catalog and add those jars and update those jars so that way you can use all the different catalog options in, let's say, Fivetran, okay, or OLake or whatever service, okay? So the problem with that is that created very fragmented support for the different catalogs. Like different catalogs were supported by different tools. So the whole point of Iceberg was interoperability. This kind of broke it. And also, when you're using like Spark, you would have to drop the jar for like your particular catalog you're using. So if you're using Nessie, you have to drop in like the Nessie jar. So what happens if you wrote a script, you're running it a year later, but you never updated it to point to the newest jar. So you're using a jar that's a year old. The catalog's updated, the Iceberg is updated, but the jar for the catalog isn't. That could break things. So there's just like a lot of friction points in this setup. So the idea is, well, how can we move away from having custom code for every catalog in every language, which isn't ideal, and move to something better? So the idea was to come up with a specification for the catalog. So instead of creating a catalog, like instead of saying, hey, this is the right Iceberg catalog that's officially anointed by the Iceberg project, they said, okay, we know that people want to use different catalogs, but what we're going to do is to make the process easier, we're going to say, hey, all the catalogs need to talk the same way. So we're going to create a REST API standard that's represented by several different endpoints that do different things, like read your listing of tables, update a table, handle different different table operations, and say, hey, when the client is asking to do something with your Iceberg tables, it's always going to do it in the same way. It doesn't matter what catalog it is. It's always going to make the same API requests. Okay. And it's going to expect a response in a certain way. So long as your catalog, so whatever language you designed your catalog in, long as it knows how to read those requests and respond to them in the way that they're expected to be responded to, according to the specification, then we only need to write one client in Java, one client in Python, one client in Rust, and one client in Go. And that means now tools like Dremio, Snowflake, etc., they only need to build support for one thing, the Iceberg REST spec. If you support Iceberg REST, then you can talk to any catalog that supports the specification. So now you don't end up having all the spaghetti code and catalogs are supported by X, Y, and then, and not B. Instead, now you have catalogs that are supported by everything because everything supports the same standard way to talk to catalogs. Okay. So when you think of tools that have Iceberg REST catalog support, you see Dremio, you see Snowflake, Flink, Apache Spark, DuckDB, StarRocks, Polaris, Presto. Basically, literally everything that supports Iceberg supports Iceberg REST nowadays. So the number one consideration when choosing an Iceberg catalog is choosing one that supports Iceberg REST support, because it's going to make sure that you have the largest exposure to the Iceberg ecosystem, that you can connect whatever tool you like to your Iceberg data. Now, as far as catalogs that support Iceberg REST, okay, I mean, as far as like open source ones, you have Nessie. Nessie is famous for providing like get-like transactions. So essentially, you can create like a branch of your catalog and isolate data and then merge the data back in. There's Gravitino. Its thing is to do like geographical replication of your catalog. Then there's Unity OSS, which is mainly really like a Delta Lake catalog, but has been adding more Iceberg support lately. That came out of Databricks, but there's like the Databricks version, Databricks Unity, and then there's like OSS Unity, separate code bases. So you always want to make sure you read the docs for the right one. Then there's Polaris catalog, which was a joint effort between Dremio and Snowflake. We jointly created a Polaris catalog, and since then it's been contributed to the Apache Foundation to become Apache Polaris, and is now a community project with all sorts of different people contributing to it from all over the ecosystem. And it's quickly kind of becoming like the standard catalog. So you have Dremio and Snowflake who have a Polaris offering. You have other companies who are building Polaris into their offerings. But REST catalog has actually really expanded since. Like now AWS, all the major clouds catalogs support REST catalog now. So AWS Glue, Big Lake, OneLake. Yeah, and then generally another nice use case for REST catalog is for like custom catalogs. So companies like Netflix, they actually have their own catalog that they build in-house that's only for them in-house. And now they're able to connect to all the tools because there's a uniform specification. People don't need to create custom support just for their catalog because they can use Iceberg REST catalog. Now, does it matter that one of these wins? Yes. So here's where like the longer term, like, hey, what happened? Why do we care about who wins the catalog war? Okay, not that it's a little war, but when you hear the hype. But it does matter, because what happens is that every tool in the ecosystem can build support for everything. Now, Iceberg REST catalog makes it where for Iceberg table operations, it doesn't matter. You can use any catalog that supports REST catalog and you're good. Okay, and you can use all the tools with your Iceberg tables. The only consideration would be the access control. So each of these different catalogs have different access control features. So like Polaris has a very robust like RBAC feature where you can really create very fine-grained RBAC rules to control your different tables and catalogs. But every catalog has some sort of version of this. Now, what happens when you go beyond Iceberg? So what about unstructured data, like photos, parquet tables, other data sets that are part of your lakehouse. Right now, there really isn't a good catalog. Like there's catalogs that track these things, like Unity and Polaris both have ways of tracking things that are not Iceberg. And then you have like other tools that can do this. And you can use like a glue for this. And you can use a Hive for this. The problem is there really isn't a API for non-Iceberg things. It's truly become a standard. So whichever catalog wins becomes the standard for how to do the non-Iceberg stuff. Okay, and the reason why that's important is because that's going to be where the interoperability is. Because every tool can build support for every catalog's version of non-Iceberg stuff. Okay, so in that case, there's going to be one or two winners when this is all said and done that are become like the industry standard. Again, these are probably going to be open source catalogs, like Polaris catalog, because it tends to be what standards rely on, some sort of open standard. And once that becomes ubiquitous, you're going to start seeing that every tool is going to build support for not just the Iceberg RESPEC, which they already have, but for all the other APIs that cover things beyond Iceberg. So then you truly will have catalogs that can govern your entire lakehouse and everything inside your lakehouse in one place across all your tools. That's essentially like the long-term sort of like, hey, where things are going, why is this important? Why do you want to follow this type story? Okay, and just to kind of tell you a little bit about Dremio and where we fall into this whole picture. Again, we do have a query engine, so basically we're used a lot for consuming your Iceberg data, and we're very fast because we leverage, like Dremio this year turns 10. This year Apache Arrow turns 10. Okay, we've been using Apache Arrow from the beginning. Okay, one of the co-creators of Dremio is a co-creator of Apache Arrow, or co-founders is a co-creator of Apache Arrow. So Dremio's been using Apache Arrow from the beginning, which you're starting to see everywhere. Now you're starting to see projects that use Apache Arrow to speed up Spark, using Apache. Snowflake has created like an Apache Arrow flight interface for flight. Everyone's starting to see the value of Apache Arrow and trying to create faster data processing. Dremio's, again, one of the companies that's been doing it longer than anybody else. And that's the reason I point that out, not like it matters whether you're first or second. The idea being that we've constantly been on the forefront of predicting what will be the standards. Okay, when it comes to Iceberg, I think pretty sure we were the first commercial company to get behind Iceberg in the sense of actually building Iceberg features into our product outside of the open source engines, because we saw that it would eventually become the standard. In the same way, we're placing a similar bet on Polaris, which is why our enterprise built-in catalog is built on Apache Polaris. So again, we're oftentimes very much not only built on open standards, we're very much involved in trying to and have been accurate in calling what will be the open standards over time. And then we have an AI-ready semantic layer. So again, semantic layers are a whole separate conversation, but the short run of it is if you're trying to create more consistency and semantic understanding across your different BI tools and your different AI agents, our semantic layer really goes a long way there. But that's a discussion for another day. Okay, again, here's the books. If you guys want to scan that QR code to download these books again. And then I'm going to just see how much time I have left. Okay, with that, what I want to do is actually, one, I'll just show you like in the Dremio UI, you can see like here's our Dremio catalog. That's again Polaris based. But you can see like the kind of interaction you have with it. It just is, and the beauty of a lakehouse in the sense that like, hey, I can just browse my tables like I would in any other database. So I can see here, like this is all Iceberg based. So I can go to one of these sections. So like here, I have like my own little folder here. And this is an Iceberg table, okay? Right there in the catalog, I can access it. And then using Dremio, I can control access to it. So I can sit there and say, hey, which users have access to it? And the cool thing is that those users can then take their catalog credentials over the Spark. And instead of running and they don't have to run any compute with Dremio, they could go run the compute in Spark using the catalog, and the same access controls will be honored. Okay. So again, the benefits of having a Iceberg catalog like Polaris, and then again, it makes it even easier when you're using something like Dremio catalog or Snowflake's open catalog that gives you sort of a hosted version of it so that we don't have to maintain it yourself. So I just want to point that out. But with that, let me just address some of the questions before I go any further. Okay, so let me scroll through. Okay.
Yeah. If you want, like, I can help you on that as well.
Okay. I mean, I think I got to the first one, so I'll just quickly read through these, and if there's any other ones,
Sure.
feel free to point them out.
Yeah.
So the first question I see from Anan: who creates the manifest and manifest list? That's going to be whatever engine is doing the writing. Okay, so whoever's the writer of the Iceberg table is going to create all the metadata. Is it the client or the catalog provider? So it's not the catalog. It's going to be the actual engine. So in this case, when Dremio writes to your Iceberg table, Dremio is writing the metadata. When Spark writes to your Iceberg table, Spark is writing the metadata. But then the catalog always gets updated as to the location of the new metadata. And then that's why, like, if I were to update a table in Spark, Dremio will immediately be able to see it, because when it accesses the catalog will be updated. Does OLake handle disaster recovery across regions? I'll let you answer that, Akshay.
Yeah. So what's the question, like?
This one is does OLake handle disaster recovery across regions?
Yeah. Like for that, Shubham answered it just below. So yeah, like for the ones that are interested, so like as Shubham has pointed out, so like mostly on the side of object store takes care of it. So like whatever object store you're using, like for example S3 or anything, like that's one of the things like AWS headache. So like you don't have to worry about it. So yeah, guys. Like I have a couple of questions that came up in the chat. So before we dive onto the site, like I have a couple of questions from my end as well. So like let's get the questions from the people answered. So like another question by Anand only. So like he's asking like who creates the manifest and the manifest list? I think you answered this one, right?
Yep, that one's
That's cool.
answered.
Yeah, pretty cool. So Anand has some another great set of questions as well. So up next is, where is the separation between Iceberg Java library and say Polaris? Does Polaris implement just the catalog and provide the authentication and authorization? And is all of the other metadata handled by Iceberg Java libraries?
Yes, correct. So the Iceberg metadata is not written by the catalog. So the catalog only tracks the location of the metadata. Now, some catalogs will do some caching. So I think Polaris does have some caching mechanisms, but that's more for performance than it is for like actually metadata handling. So again, the writer will typically use the Iceberg libraries or create their own custom libraries that write to the spec and write the metadata. As long as everyone writes metadata that follows the specification, then any other engine can read it. But generally, the engine doing the writing is responsible for having the right libraries to write the Parquet files the right way, to write the manifest list, and then the metadata.json, and then to connect to the catalog and update it. So it's always the burden is always on the writer to do that. And again, if the writer is written in Java, it would use the Java libraries. If it was written in Python, it would use the Python libraries. So it just depends on the language.
It's cool. Nice. So up next is a question from Badal. So like he's asking like a simple question, like in a slide you mentioned about Dremio using Aeroflight and ADBC drivers. So like like he just wants to know more about it, how you guys are implementing that.
Okay. Okay. So basically, there's two sides of the Arrow project. Arrow started off as an in-memory format. So the idea is that one of the things you have to do when you process data is that it's not just the file size, but I have to read the file and then load the data into memory. And depending on how I represent that data is going to affect, how fast I can then operate on that data. So the part of the Apache Arrow project was to figure out, hey, how can we best represent data as a columnar format in memory to, one, fit the most amount of data in the smallest amount of memory possible, and also operate on it as fast as possible. So essentially, the benefit of the Arrow project is that when you do data processing in Arrow, is that when you load the data, you can load up a lot more data in the same amount of memory. So that means you need less memory to do the same transaction. So right there, you're already starting to see price performance because you don't necessarily need the same level of compute to do the same transaction. So you can get much bigger transactions done in a smaller amount of memory. Two, it's because it's a standard format. So the idea is that what happens that people did columnar formats before. This is every system did their own. Having a uniform one allows the data to be transferred in the same format. So the other part of the project is something called Apache Arrow Flight, which is a protocol it's like an ADBC is essentially like a replacement for JDBC, ODBC, that instead of transporting the data as rows, it transports the data as Apache Arrow. So that way, when the data goes from because right now, if you're using JDBC, ODBC,
Mhm.
and you're using columnar data, you load up columnar data from, let's say, your data warehouse, and then it has to be converted into rows for JDBC, ODBC, and then on the other end, converted back into columns. So you spend
Uh,
all this time converting data. So with Apache Arrow and Apache Arrow Flight, you keep the data in Arrow the whole time from system to system. So when you have large amounts of rows, that can actually really make a huge difference. Like there is a video on YouTube where I run like a Python ODBC script, and then I do the same thing in Arrow Flight, and you can actually see how fast one finishes versus the other, which is one, like I think the ODBC one took like a minute, and then like the Arrow Flight one took like a few seconds.
yeah.
And it wasn't because the query didn't go any faster. The query was the same. It's just the amount of data it took to transport the data because of the conversions that took all the extra time.
Yeah, that's good. Like, so like if we have a video, like it's pretty good, like people would get a good hands on. So like the next question is by Shubham, like one of the very integral questions around the complete, I would say, this session. So like what are the deployment methods for Polaris, and is that scalable if used on scale? Like because it's like at the end of it, it's a open source software, like
Yep.
it's at an incubating stage. So like there are a lot of questions that are buzzing up in the people minds and also around
Now,
the adoption. So like what do you think around it?
I know specifically, especially like the developers from Dremio, we've been very focused on trying to make sure that the open source project is scalable and production ready.
Yeah.
So a lot of so a lot of the contributions that Dremio has made recently are things like making sure that you can use different backends, like using like a Mongo as a backend to your Polaris server.
Hmm.
Um, investing in creating Helm charts, so that way if you want to deploy it to Kubernetes, it's much easier because the Helm charts are already made. So basically, a lot of the infrastructure is there for you to easily deploy it into your Kubernetes environment in a scalable way. With production grade storage, or with a production grade backend. But that's if you want to deploy it yourself. You don't have. The great thing about Polaris is you got a couple different options where you can host it. So Dremio again can allow you to host your catalog pretty much for free.
Hmm.
You are going to see a revamp of our cloud product in like
Oh,
the next month, and you'll be able to sign up and pretty much get a free Polaris catalog. It'll just be there. Like you can sign up for free and you can use the catalog. Hopefully you also want to use the Dremio engine, but you don't have to. You can just use the catalog, and that catalog piece will be free.
pretty good.
But you could also use Snowflake's open catalog. It's not like you getting an open catalog is free, but there are charges for like API requests. So if a lot of requests are coming into that open catalog server, you will consume like Snowflake credits. But the cool thing is you have those options. And again, you don't have to use Snowflake or Dremio to use our Polaris offerings. You can just sign up, have it, and then connect it to Spark or connect it to whatever compute tool you're using, because it's all REST catalog. Okay, the beauty of REST catalog is interoperability. So very scalable. You have options on how to deploy. So it's a pretty cool project.
Nice, nice. So, guys, while we are answering all of your questions over here, so like if you guys want to jump onto the side of even how to go ahead and work around with OLake by using Polaris, just go ahead and look onto this particular blog. So, like, I was one of the authors of this, so like we just wrapped it out, and it's been a pretty great insight of that. So, like, if you guys want, you can go ahead and check it out. But yeah, like diving on to the next set of questions. So, one question is from Shitij. So, like, he's asking like if two separate REST catalog instances are connected to disjoint Iceberg table backends, like example, different S3 buckets, but configured to share the same exact catalog name and namespace, what happens if both attempt atomic commit with identical snapshot IDs? Wow, pretty long question.
Okay, so if two separate REST catalog instances are connected to disjointed Iceberg table backends, like different S3 buckets. So again, I mean, just there, I mean, you could have different catalogs that point to different. And again, let me just, when I say different catalogs, there's a couple different ways we can think about this. Like maybe we were talking about like, hey, I have two different catalog services. Like I have a Gravitino and a Polaris running at the same time. But also within Polaris, you can actually have multiple catalogs within Polaris. So something to keep in mind. And then those catalogs can actually point to different storage locations across the different clouds. So I could have one catalog in Polaris that's pointing to like a bucket in Azure, and another catalog that's pointing to a bucket in Google, and so forth. So you do have that functionality, but configured to share the exact same catalog name and namespace. I don't know if that would be possible. depending on the tool, because like generally like the catalog namespace is going to be determined in the engine. So for example, if I go to Dremio and I'm adding multiple catalogs, each catalog is added as a source. So let's say they both have a table that's called accounting.sales. The catalog has to have a name itself. So when I go to Dremio and I add the first catalog, I might name it catalog, but I can't name the second catalog. I'd have to call it catalog 1. So then even though they're both tables are called the catalog accounting.sales, the first one would be like catalog.accounting.sales, and the other one would be catalog 1.accounting.sales. Same thing in Spark. I wouldn't be able to create 2 catalogs within my Spark session that have the same top level namespace. I'd have to configure each catalog separately and put the settings for that specific catalog, so that prevents the possibility of you having like the same exact namespace pointing to 2 different tables in the same tool. Because there's always like this catalog namespace that's not decided by the catalog but by the engine.
Yeah. Nice. I think that would have answered your question, Hitesh. A pretty interesting one. I guess like this is gonna be one of the last questions before we dive on to the question from our side, because I'm also pretty curious at my end. So we have this question, I guess. So like this is again from Anand. So like he's asking, like, for DR and Iceberg spec, the manifest have full path. What happens with DR who updates the path? I think DR it means.
Disaster recovery, yeah.
Yeah.
Yeah, I have written a blog on this, and it is
Oh.
messy. this is the I think this is like the current area for innovation in Iceberg. Now there's 2 stories here. Under the current specs of V2, V3, full path, absolute path is still the thing. So basically, bottom line is the metadata is going to have absolute paths. So now when you recover, there's a couple different questions. One, when you recover the data in your storage, are the paths the same? If the paths are the same, then you don't need to update the metadata. The metadata will continue to work. But if you if you restore it to like a different bucket name, then the metadata breaks. Now there is a Spark procedure that was added that allows you to rewrite the storage prefix. So there is a solution for that. So you can use that tool to then rewrite the metadata to swap out the prefix to the files. So there is a solution to that. But there's the other problem is when you restore, it doesn't update your catalog. So your catalog might be pointing to, let's say, snapshot 10, but your backup is all the way back from snapshot 8. So now you have metadata for snapshots 1 through 8, but you don't have metadata for snapshots 9 through 10, which is what the catalog is referring to. So then you have to go to the catalog and then update it and basically roll it back. So for that, you would probably like just remove the table from the catalog and then use the register table procedure to then register it with the metadata JSON you do have. Yeah. Now, my advice there is you're going to want to, whenever you do backups, you are going to want to also keep maybe like in parallel, create a backup of your catalog references. So that way you have a listing of like, hey, when I backed up the data, what is the current listing of like table to location? So that way, if you have to back up to a certain point, you have that listing. I'd imagine that in the future, more vendors that provide catalog services will provide more disaster recovery services, but they haven't gotten there yet. Like right now, the focus has been optimization of tables. Once optimization of tables is kind of played out and like that's pretty well figured out, I would imagine that the next step will be disaster recovery services. Mm-hmm. But also in V4, but V4 is just starting to come together. So you're talking about 2 years at least before V4 is a thing. That will have relative paths. So that problem will go away eventually. But how relative paths will work is still being discussed. Again, a lot of other features for V4 are just in the early stages of discussion. So you're really looking at a couple of years. Like V3 just got approved. So you're looking at a couple of years before V4 is really a thing.
Pretty good. That's nice. So yeah, guys, I'm seeing a lot of people have also joined in from the various set of other companies. And if you guys are interesting and like you're looking forward to join onto our various sessions at OLake, as stated, we have such kind of sessions every other month where you invite our speakers. And like before I dive into my set of questions, I have a couple, so won't take much time on that. So like I'm seeing a few people that have joined us, like from the various companies, like Shinji, Dipesh. All you guys want to go ahead and scan these QR codes, jump onto our Slack where we have discussions, and like as Alex stated, go ahead and join the Apache Iceberg. Slack as well. So like I'm one of the person there. Like I had good sort of conversations, and we also have a channel there as well with the name vendor OLake. So like you guys, if you want, you can check that out as well. So yeah, okay, let's go on to the side of questions that I have. So like I have a couple of interesting ones, some heated ones as well. So like all up to you. So yeah, like one of the questions is like there are a lot of companies and a lot of organizations out there working on with different catalogs, and they are experimenting as well. So like there are different, like as you stated, like there's it's a catalog war that's going on, right? So like if for example if someone is part of a company and they just go around and look around of changing the catalog, like for example in a day or two, like how much time, or like what's the number one fear that would be there in that person? Like is it be something around ACL drift, or like query breakage is of course gonna be one. What do you think?
Um, it depends. I mean, honestly, you'd like ideal world is you'd want to take advantage of a catalog feature called credential vending.
Mm-hmm.
So now what credential vending does is that right now, like to avoid like right now or before credential vending, what you would have to do is you'd have to provide a user credentials for the catalog, and they'd have to have storage credentials. They'd have to have credentials for S3, for Azure, for Google. And when they would configure Spark, or when they would configure Dremio or configure any of these tools, they would have to give both sets of credentials. They have to say, hey, here's how you talk to my catalog. Here's how you talk to my storage.
Yeah.
Okay. So now if you switch catalogs, your storage credentials don't change. So it shouldn't really matter from the catalog level. You would just provide the different catalog credentials, and then the catalog would just still point to the same storage locations and use your same storage credentials. So there shouldn't really be any drift there. But the problem is you're still giving, what happens if someone doesn't have access to a particular table, but their storage credentials do have access to the underlying storage? Okay, they could get around the catalog and access the table directly from storage. So even better is if you use a catalog that supports credential vending, which Polaris is a catalog that supports credential vending.
Yeah.
What it does is that when instead of you having to provide catalog credentials, now I'd only give the user one set of credentials, the catalog credentials. And then I would give those credentials to Dremio, I'd give those credentials to Spark, to whatever tool. And then what would happen is that when the tool connects to the catalog and says, hey, I'm looking for this table, then the catalog would actually create a temporary set of credentials for that transaction. So the user doesn't have storage credentials, but the engine gets temporary credentials to do the transaction. So that way you can read and write to the table. So basically the catalog is the only way you can read and write to the table. There's no workaround. I can't go to the storage directly because I don't have my own storage credentials. They're only given to me temporarily by the catalog. So it makes it's a much more secure, and it's also more easy because then you're not having to track so many credentials. Like now when I go to Dremio and I connect to my Polaris catalog, I just enter my username and my key, and then I'm good to go. I don't have to enter all this other storage stuff. I don't have to worry about all these other storage settings. The catalog's already aware of them. That would be some of the things I think about when migrating between catalogs. But there is a tool in the Nessie repo for really easily moving data from one catalog to another. Because again, it's just you basically just run the command and it'll take all your tables and move all the references over to the new catalog.
Very, very interesting on that. Like, I'm sure, like if someone out there wanna look out for migration, they surely wanna check it out. Like one of the last question I have. So like I don't know, like if you like, of course you are great on the LinkedIn sites. Like I posted a couple of days ago, right? So like not every other organization wants or like look forward to working with Apache Iceberg, right? Because as some are dealing with only like few GBs of data, they don't require that kind of mindset or scalability. But as per you, like what do you think, how is the Apache Iceberg ecosystem being evolving? Like as we have other set of competitors like Delta Lake and other Hoodie, so what do you think, like how is the ecosystem being evolving on this side?
I mean, I think Iceberg at this point is the de facto default. So the way I would think about it is that nowadays, if you're just getting into the lakehouse space, the way to think about it is it's Iceberg by default, unless you have a good reason to use Hoodie or Delta. And I mean, the reason you would want to choose Delta is maybe like almost everything you do is Databricks. So in any case, if you want to get the best Databricks experience, you might want to use Delta a little bit more. But again, you do lose some interoperability when you're not using Iceberg. So the question is like, how important is that to you? Hoodie, maybe you're doing a low latency, you're trying to do really low latency streaming ingestion. In that case, maybe you want to use Hoodie. A lot of people, use a service like, let's say, OneHouse to do Hoodie ingestion and then convert it to Iceberg. Maybe, but again, if it's not one of those use cases, then Iceberg is the default, and Iceberg should be what you're using, and using services that ingest your data into Iceberg. Because the thing is that while there are tools that can convert between formats, the format you write in determines a lot of things. Like, for example, if you want to use Iceberg features like partition evolution and hidden partitioning, you have to write to Iceberg. You can't write the Delta or Hoodie and then convert to Iceberg, or else those features just aren't things you can take advantage of. So I would say that right now, the environment is Iceberg is the default, unless you have a good reason not to use Iceberg, just because the ecosystem is so overwhelmingly big at this point, as far as the tools you can use, the support for it. It's overwhelming. Polaris is not there yet, but I do predict that Polaris will have a similar motion over the next couple of years. Just because, again, eventually, as people get their Iceberg lake houses in order, people then are going to start really thinking more about what about the rest of my lake house, and they're going to start thinking about sort of like how do we create the same level of interoperability for everything, and that requires standardization of catalog.
Yeah, that's interesting. So like, yeah, guys, as you heard, Alex, like it's very necessary to go ahead and jump onto this side of ecosystem. If you're looking for such kind of alternative to help you on that note, you surely want to go ahead and check OLake. So like, just go ahead and search olake.io and you will be greeted off with the section, and go ahead and give us a try. Like, it's just a few set of commands. And yeah, like very next, last question, completely last of the last, we have one, like I have like something from my end as well, right? So what do you think, if there's someone working on with different set of catalogs, or depending how, like you might have even worked, like if you just go out there and like out on a scale of 1 to 10, how will you rate these catalogs on the interoperability side, like on a 1 to 10, like AWS Glue, like, or even if you are using Lakekeeper, Unity, what do you think about it?
I mean, all the Iceberg catalogs, like as long as it supports REST catalog, they're all going to have all the interoperabilities. Like basically, you support REST catalog, you get a 10. Now, I will give AWS Glue an asterisk, just because it wasn't built originally as an Iceberg catalog, so it can handle other things, but strictly within AWS. So if your whole world is AWS Glue catalog can allow you to track other things, a lot like Parquet tables, Iceberg tables, Delta tables, Hoodie tables, in one catalog and govern them. But again, you're locked within one cloud. It doesn't really work as well when you're going cross clouds. So again, some of the open source options, the Polarises, the Gravitinos, the Nessies, are going to give you better cross cloud functionality. But again, they're not ubiquitous enough that necessarily every tool has built support for the non-Iceberg bits of those. So again, that's why eventually when there has to be an open source standard that kind of becomes dominant to start developing those non-Iceberg standards.
Okay, cool, guys. So like we have also published a poll if you want to just go ahead and drop in your thoughts on that. So yeah, it's gonna be like we have approached the end of the session. So the ones that have tuned in, we actually loved your set of questions and everything you went ahead and added on to the session. But yeah, most importantly, Alex, thanks a lot for your time. Thanks a lot for being the speaker for this session. And of course, like every other person out there in the data engineering field might have read your book or have seen your blogs. So pretty interesting side. It's been great pleasure from the team at OLake to invite you over here, and we're looking forward for some more such cool sessions. And it was great to have a session, but at the same time a cool podcast of questions. So that was pretty interesting. And yeah, so as we have shared, guys, go ahead and connect with Alex, and we will be bringing more such cool sessions over here at OLake. And yeah, so it's gonna be a wrap. And have a blessed good night. If you're from India and if you're tuning us from here, have a good day. Bye bye.
Everyone, ciao.
Bye bye.